In this video, we have two problems involving trigonometric or inverse trigonometric functions. And if you're taking trig right now, and you're working with these kind of problems, you'll also see some of these later on if you take calculus. So for the first one, we have if y is equal to arcsecant of the square root of 5 over 2, we want to find y and tangent of y. I have a right triangle here, and what we're going to do is label the sides of this triangle based on this information. So the fact that we have y equal to arcsecant of the square root of 5 over 2, that tells me that the square root of 5 over 2 is the angle whose secant is the square root of 5 over 2. So this represents an angle. Dealing with the inverse secant here, in arcs so we can say inverse secant or arcsecant of the square root of 5 over 2. That means that this is the angle, that is, y is the angle whose secant is the square root of 5 over 2. So based on that information, we know that the secant of an angle is the hypotenuse over the adjacent side, just the opposite of the cosine. So I can put the square root of 5 here and a 2 here, and we know that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So squaring the square root of 5, squaring this, subtracting it, we get 1, and the square root of 1 is 1. So that's the way it's labeled. So from the triangle, we can see that the secant of y is, again, hypotenuse over the adjacent side. Now we want to find the sine of y. This is the angle y. The sine is the opposite over the hypotenuse. So this would be 1 over the square root of 5. And we rationalize this, multiply by the square root of 5, numerator and denominator. I get the square root of 5 up here over 5. And if they ask you for an approximation, you can use your calculator to whatever decimal places they ask you. And then for the tangent of y, again we refer to the triangle. Tangent of the angle y is the opposite, which is 1 over the adjacent side. This is 1/2. So those are the values for part 1 here, problem 1. Now for number 2, we have if y is equal to arc cosine of 3x, find cotangent of y and sine of y. So again, y is the angle, whose cosine is 3x. So that's what this is saying. You see y equal arc cosine. Sometimes it's just say inverse cosine. Arc cosine and inverse cosine, the same thing. Just like this over here. Arc secant and inverse secant, or secant inverse, same thing. So this statement here means that y is the angle, whose cosine is 3x. Or we can write this as 3x over 1. And the cosine is the adjacent over the hypotenuse. Now we have to complete the triangle then. So remember, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So this side would be 1 squared minus 3x squared, which is 9x squared. And then it would be a square root. This would be 1 square root of 1 minus x squared. You can check it out. This squared gives you 1 minus 9x squared. This squared gives you 9x squared. If you add them up, the minus 9x squared and the 9x squared cancel. You get 1, and the square root of 1 is 1. So from this triangle then, you can determine that the cotangent of y is equal to the adjacent side, opposite of what the tangent is. So this would be the adjacent side, which is 3x, over the opposite side. This is the square root of 1 minus 9x squared. That's the cotangent. And for the sine of y, it's the opposite over the hypotenuse. So it'd be the square root of 1 minus 9x squared over 1, which would just give me the square root of 1 minus 9x squared. These are the two answers for problem number 2. Thanks for watching. We'll see you next time.